Hello, this is a video where I'm going to show you the basic commands for Matlab, and it will be followed by a second video where I'll show you how to create M files. We're going to start by looking at the environment. We open up Matlab. We have the current folder, all the files that are in the current folder appear in this part of the window. Then the workspace is where we're going to see all our variables that are created. At the moment it's empty. And this window here is the command window with this symbol. That means that is the current line that will be executed. This particular line works like a calculator at the moment. For example, I can set up a variable a, make it equal to 2. It displays the result and it's creating a variable in memory in our workspace, and that's a numerical variable and it's equal to 2. Okay, if we don't want to see the result, I can use the arrows. The up arrow will bring the command that I just typed in. If I put the semicolon, I don't see the result of the action. Okay, so let's say we can make a equal to 4. That will overwrite the value. If you see here, a is equal to 2, it exists, but now by doing a equals 4 semicolon, we don't see any result on the command window, but the value in memory has been updated. We can also create a variable that is a calculation. It can depend on numbers or it can depend on variables that are in memory. So for example, a cubed divided by brackets 5 minus 2 times square root of a, or a to the power of 0.5. That gives me our result, b equals 64 on the screen. Because I didn't put the semicolon, remember the semicolon prevents the result from being displayed, and it's also in memory. So far the variables that we have, a and b, contain one numerical value, but we can create variables that contain a range of values. So we can create an array, u equals, and we can separate square brackets to denote that it's an array, and then we can put our values, and that's our array, and u is in memory as an array. You see the difference between an integer, just one number, and an array of numbers. In this case I used comma in between the numbers, and that creates a horizontal array. We can create a column array, say we call it v, and instead of commas in between each of the values we put semicolon. The semicolon means go to the next column. And if we run it, go to the next row, okay, and you can see now we have a column array instead of a row array. As well as creating arrays horizontally or vertically, we can use by typing each of the numbers, we can use a command to create a range of values. So we say d equals 5 to 10. That's creating an array with all the numbers between 5 and 10 in an array. By default, the increment in the array, see in this example, we've just used the first value and the last value, and the increment by default is 1. So we've gone in steps of 1, 5 goes to 6, 6 to 7, 7 to 8, 8 to 9, and 9 to 10, and we stop there because that's the final value. But we can also create a different increment. So for example, we can overwrite our d array, and we can say it's going to go from 5 to 6, but in between we select what the step size is going to be. If we don't put anything, it's 1, but we can say now we want increments of 0.2, and that's going to create an array that goes from 5 to 6 with an increment of 0.2. Okay, at each step there's a 0.2 difference between one value and the next. We can also create a matrix by saying the name of the matrix equals square brackets, and inside the square bracket we separate the elements on the first row with commas, then semicolon will take us to the second row, then we type in the values for the second row, semicolon to go to the third row, and then commas in between the values of the third row. And that's our matrix displayed because I didn't use the semicolon at the end, and we have it in memory here the way we wrote it. Now, how do we access individual elements of this matrix? Well, we're going to use the notation aij, the same you do in your maths class, but we need to give values to those I and j values. So for example, if we say a2, 3, That's going to access element on the second row here, and third column, so that should be equal to 4, and that's your value. Oops, there, 4. We can also access a full row or a full column of a matrix. If we say A colon for all the rows, comma 1, that will give us all the values in the matrix A in the first column of the matrix A, so the 1, 3, and 5. So the colon replaces all the rows, or we could put it as all the columns. Okay, so we could have said A row 1, comma, and then give me all the columns in row 1. That's going to look to A. If I scroll up for a second, we look into A and look at the first row, and it gives us those values 1 to 2, and that's what we got over here. We can also get parts of our array. If we say A 2 colon 3, we're gonna get our elements 2 to 3. If we want to clear the screen, okay, so we can't go back and change these values here. The only active line on the screen in the command window is the current line with the 2 greater than symbols. That is your active line with the FX. Everything else is just a display of what you've done. If you want to delete it, you type in CLC and that will clear the screen. The screen, it should clear like that, and then you have no history left. Now the command history is still present. If you use the arrows, you can still see everything you typed in the current session, and you can reproduce it again. Okay. Okay, now we're going to move on and we're going to create basic plots. We can do plots in 2 dimensions and 3 dimensions in Matlab. It's quite powerful to create plots. We're going to start with a 2-dimensional plot. So we're going to create, for our kind of technical data, we're going to create an array of x values that go from -2 in increments of 0.001 to, remember the colon to create those increments, to 2. That's our x. Okay, and because I didn't put the semicolon, we see all the values for x, and because our increment is so small, there's loads of values in there. Okay, so we go from from -2 is the initial value to +2. So if I can get the first value there, we start at -2 with our very small increment, increasing incrementally until we get to +2. Okay, so that's our x-axis. We have decided what the x-axis is going to be equal to, and now we're going to create our y value. Y equals, and it's going to be x squared. Okay, now if we just type in x squared, remember x is an array. We can see it here. There's 4001 values in one row going across. In Matlab, every variable is a matrix, and you kind of can guess it from these symbols here. Even when you just have one entry, one number, one real number, it's in a matrix. It's just a matrix with one element. If we try to do x, which is an array with 4001 elements, squared, that's x multiplied by x, what Matlab is going to try to do is matrix multiplication, which is row by column. And you have a row with 4000 numbers, but then x, when you multiply the second x, is another row with 4000 numbers. If you remember from your matrix manipulations, if you're going to multiply 2 matrices, your number of columns in the first matrix, which is the 4001, has to be equal to the number of rows in the second matrix, which is not the case. So what we actually want to do with this x squared is we want to square each element. We want to take the 2 and square it. We want to take the 1.999 and square it. So we want to perform the calculation element by element. And to do that, you put a dot before the calculation. That means you're telling Matlab, forget about matrices. You're taking each element of x individually and squaring it. Okay, and that's going to give us another array of exactly the same size, 1 by 4001, where each value, we'll just look at the last one, its value is the square of the original x value. So the last number we have in our array y should be 4. Here we can get down there. That's your 2 squared. and the initial value should be 4 as well, because minus 2 squared is 4. Okay, so at this point we have our x and y values. So we've created our little x and y table like we do in maths when you want to do a plot. And the command for plot in Matlab is plot for a two-dimensional x and y scatter. And you just decide what to plot. In this case, we have an array called x and an array called y. And that will give us our graph with our x squared graph. If we want to add another plot into the same figure, on the command window, we're going to say hold on. That means that the next plot command that comes in is going to be plotted on the same graph. If we didn't use hold on, the new graph would replace the old graph, and we only have one graph available at a time. Okay, so let's say our y now is going to be equal to x, and we repeat the plot x comma y. That's the new y, and that's going, or it should be going, into the same graph. Here you go. So the orange brown is the x equals y from minus 2 to plus 2. Sorry, the y equals x, and the quadratic equation is your x squared graph from minus 2 to plus 2. So the x-axis values are the same for both, and it's the y-axis that is changing. Now we want to type in hold off once we're done adding graphs into the same figure. So the next time we plot a graph, it will be replaced. So we want to save this graph, you need to save it separately. The default format for a Matlab figure is .fig. If you save it with this format, that means that later on you can reopen it and change it. You can also, once you're sure that you don't want to make any changes, you can make it a JPEG or a TIFF or an EPS, BMP, any kind of file, figure file or picture file format. But once you do that, you can't go back and edit the figure. Okay, so my advice is always save them as a Matlab figure and as whatever other format you want to use if you want to insert it into a report. Okay, so for the moment we're not going to save this one, and I'm going to show you what happens if we plot a different one. So let's say we do y is equal to 3x now. I'm going to put the semicolon so we can see all the points, and I'm going to plot x comma y. Now this is the new y, which is 3x. Because I did typing hold off, this new plot will replace the plot we had earlier, the two graphs, and this is a new one. Okay, so remember, if you want to plot more than one function on the same graph, make sure that you plot the first one and then use the command hold on. Plot any other extra functions you want to have on the same graph, and once you're done, hold off and save your figure. Okay, now on our figure, we're gonna add labels. There's several ways of doing this. You can say insert, and you can insert your X label, Y label, your title, Z label if it was a three-dimensional. Okay, but we're gonna do that using the command line. So the same, exactly the same command can be that we can see on the menu on the graph. You can say X label, and then you put a text. It goes from minus 2 to plus 2. Okay, we use single quotation marks for our text. And if we look at our graph, that has gone in exactly the way we typed in. We may want to add some spaces. There, I'm just editing and adding some spaces to my label on X so it looks slightly better. There you go. That's nicer to look at. Okay, we're gonna do the same with the Y label. You put your text, Y equals, in this case we have 3x. If we look at our graph, that's your Y label. If you come to the graph, you can actually just edit. You can edit the axis properties, the figure properties, and so on. Okay, let's look at adding a title. title, and then again you just put your text, plot example, close the quotation mark, the single quotation mark, close the bracket, and if we look at our graph, that's our title. Okay, and we can also add text within the graph, just pointing out a particular point that we want the user looking at our graph to pay attention to. We can say text, point 5 is the location where I want it, and then what text, attention to this point. And if we go to the graph, that's where it is at point 5. We have our kind of message to say that this is a point that the user should be watching out for. Okay, and finally we're going to be looking at creating our X and Y plots. Remember when we had the two different functions, the Matlab just chose what colors to use, but let's have a look at kind of customizing those a little bit better. Okay, so say we have our plot XY. Instead of just plotting X and Y and letting Matlab choose what to plot, we're gonna say put this in red. You can see there, yeah. So or will be a red. Then we're gonna plot. You can also add two plots by having on the same bracket you continue. So we'll have XY, and then we're gonna plot X, comma, and I don't have another function, but I'm gonna calculate it on the fly, 2 times X. And this one I'm gonna plot it green color, and instead of just a solid line, we're gonna have X's marking each of the points. Okay, let's have a look at how this, oops, I can get the graph. There you go. So you have the XY plot is the red. That's the initial graph, and we just said red, so that gives you a solid line. This one here is the green, and it's X's because there's so many points you can't see. Let's see if we can zoom in. So you can see if you're plotting, if you're printing on a black and white printer, you may want to select these kind of shapes so you can see the difference between one graph and the other. Okay, there is also different, you could have circles. Again, there's so many points that we can't see it very well, but if we zoom in, you should be able to see there. So that your points are just dots. Okay. Okay, so this is the first video. You have on page 22 of your notes, you have all the different commands for the different colors that are available to you and all the different styles. So you can have dots, dotted line, crosses, solid lines, stars lines, and so on. There's all sorts of different options. Okay. You can also customize your axis. Now remember that once you have a plot, let's just go back to our plot, you can also use the menu. You can insert a legend that tells you what each, oops, if it works, what each of the lines are. There. In this case we didn't name them, so it's just telling you data 1, data 2, but you can edit those values and change the name. Let's say we just call it Y1, and data 2 we're gonna call it Y2. Okay, so remember, every time you're creating a graph, you need to have a legend or somewhere where you explain what each of the lines means. You need to have labels for your axis. Again, either insert axis, X label, Y label, or you use the command line to insert it. Okay, so in the next video we're going to look at how to create M files. Bye.